All right. So conditional probability, it's basically taking two events, but it's saying what's the probability of this event happening given that this other event has already happened. Okay, so it's basically saying there's a condition, putting a condition on the probability. Like this thing must happen, and then what's the probability of the other thing happening as long as that first thing did. All right, now there's a couple different ways we can represent conditional probability. Probably the most straightforward way is in something called a two-way frequency table. Okay, or could be called a two-way probability table, especially when we start looking at things that have just too many items to write in the frequency table, like millions of responses. It's harder to read a frequency table when you've got a million responses spread out through a table. It's easier to just look at probabilities. So we will at the last few slides talk about, well, what if we just have probabilities? How can we find these conditional probabilities? So a two-way frequency table displays the frequency of data in two different categories. Okay? Two different categories. Right? And it'll be, that may sound confusing, but the example we show should make it pretty clear. Right? And the example we're going to use on the first handful of slides is one where people either passed or failed their driving test, or they took a class or did not take a driving class. And this is the frequency of the people that did this. So this bottom right corner, that tells you the total number of students or total number of people, 80, right? And we can get to that 80 number a couple different ways. If we look this way, the number of people that passed was 50. The number of people that failed was 30. Gives us 80 total people. We also could use the rows, and we got 39 people took the class, and 41 people did not take the class, giving us a total of 80 people. All these numbers on the inside are the number of people that did a combination of things, like took the class and passed the test. 32 people did. Failed and did not take the class. 23 people. All right, so we'll be using this table for the next few slides. And we got copies of it. So question one, what is the probability that a randomly chosen student took the class but failed the driving test? Okay. So we need to basically look at the rows and columns and kind of figure out where the intersection is. So took the class but failed. It's like 7 students. Now it's telling us where to look. The probability that a randomly chosen student, well, that's of the 80 total. We had 70 out of 80. So this represents our probability that somebody randomly chosen took the class but failed the test. So pretty straightforward so far. What's the probability that a randomly chosen student did not take the class but passed the driving test? Did not take the class and passed. That'd be 18 out of our 80. My recommendation with all probabilities that can be reduce them. Just the smaller numbers are usually easier to work with if you're going to use them later. And I think they're just easier to comprehend. It's like 9 over 40. I think it's pretty straightforward when you're just talking about the probability out of everything. Where it gets a little more difficult is where you start putting a condition on things, where you start narrowing your scope down. And that's what's happening in this example. It says, what is the probability that a randomly chosen student failed the driver's test given they did not take the class? All right. The key we're seeing here is this given part. Okay, given that they did not take the class, that tells us that that is our condition. All right, our condition is that they did not take the class. So really our focus should be on that row of our condition. All right, this is, in this case, it's a row because did not take the class was a row. All right, so I'm really only looking at the probability of somebody who failed the driver's test out of the total number of people that did not take the class. So in this case, it's going to be our 23 out of 41. Okay. This is conditional probability. Okay. Conditional probability, where we focus in on what's been given, okay, our given statement portion here, right? That's what we focus in on, just that row or column. The next example we use has we're using a column. So that covers our, okay, just the introduction to our conditional probability. Let's look at another example. They have another given statement. Given that they passed the test. So let's read it all. What is the probability that a randomly chosen student took the class, given that they passed the test? So when you guys are taking your end of course tests or one of our tests at the end of this unit, once you know what the condition is, kind of cover up everything else. Focus on, like I can draw on mine. And on your Edulastic assignment, you can use the drawing tool in there if you like. And of course, I don't know if there's a drawing tool on the end of course. I don't think there is. So you may just need to cover it up. But we're just focusing on this section. Right? So took the class. 32 out of 50. So 32 students took the class that had passed the test. Okay? Because that was our condition that they passed the test. So 32 out of 50. I like it when things reduce down to 25ths, because that tells me that it's going to be a real easy thing to convert to percentages. This one will be 64%. The whole number percent, which is nice. Right. As I mentioned earlier, sometimes we use frequency tables and the frequencies just, they get too big. Okay, there's just too many things and too many numbers there. The numbers are too big. You can still use them, but the numbers get so big that it's easier to think of each of these boxes as just the probability of that box occurring out of the whole. Okay, so where again these probabilities would end up being decimals, but you could round your decimals. It could be like 0.8% of the time, or 0.8 is the probability of passing the class, and took the class, 0.8 of those people passed, 0.2 failed, and things like that, where you could get some percentages that all those percentages add up to 100%, okay? And you could use those, and we're gonna actually use some percentages to find the conditional probability on the next few slides. Okay. Now, we don't have a two-way frequency table, but we do have a formula. So for two events, A and B, the probability of B occurring, given that A has already occurred, right? We can use our probabilities to find these, right? And the formula is right here. And we're going to use it on a couple examples. But the way this is read is the probability of B happening given A. That vertical line, and that's our notation for the word given. Okay? It's telling us what our condition is. The condition is that A happens. Right? We don't know what's the probability of B happening given that A happens. Okay? And the way that we'll do that is we need to find the whatever the probability of A and B happening. Okay, if both things happening. And we divide it by the probability of A happening. Okay, this is the formula we're going to use. Now it says where the probability of A does not equal 0. Well, if the condition is that A happens, then our number, then A, probability of A won't be 0. Right? We wouldn't be computing this if the probability of A was 0, because then A would never happen. The condition that we're trying to figure out isn't happening. Remember, and that's a multiplication. Okay? And is multiplication, or would be addition. So in this case, we want to know what the probability of A and B are. We have to multiply to get that probability. Now we do that work for you on this example. So no two-way frequency table here. This one's just the percentages. In a survey of pet owners, 45% own a dog, 20%, 27% own a cat, and 12% own both a dog and a cat. Okay, we did the work for you. We figured out what both of these things together, right, are. When they both happen, it'd be 12% of the time that you own both a dog and a cat. All right, let's use our formula to answer a couple questions. Now, typically, the word given is the thing that's going to identify the condition. All right. Sometimes it's not given. Sometimes you're told this happens. What's the probability of, like in this case, what's the conditional probability that a dog owner also owns a cat? All right. So in this case, there's no given statement. All right. But they're saying what's the probability that a dog owner? So that is the condition, that you're a dog owner also owns a cat, all right? So that's why it's written, it looks backwards when we look at it in the probability format. Another way to write this would be, what's the probability of owning a cat given that they also own a dog, or that they own a dog? All right, so in this case, there's no given, but because they're starting with what's the condition probability that a dog owner, right, also owns a cat, that is the conditional part of our probability. So here's what we're going to do. We need to know the probability A and B divided by the probability of, I should have said B and A. Okay, but divided by the probability of A. Whereas this would be B, this would be A. So the probability of both things occurring, we said it was 12%. I'm going to write it as a decimal. Divided by the probability of just A, which is owning a dog, which is 45%, 0.45. Let's see, 0.12 divided by 0.45, 0.26 repeating. So if I round to two places, 0.27. Which is 27%. We leave it in the same probability format that it was given to us, percentages. We're to factor it at 27%. All right. One more example. What's the conditional probability that a cat owner also owns a dog? So it's flipping it. It's saying the condition is that it's a cat owner, right? Also owns a dog. So our, again, we wanted to rewrite it as given statement. It'd be what is the condition, or what is the probability that you own a dog given you are a cat owner? All right. So we'll say BA divided by the probability. Okay. And just rewriting the formula from a couple slides ago. So owning a dog and a cat, that was our 0.12 again, or 12%. But now owning a cat, that's less. That was only 27%. I'm feeling this is going to be another decimal that we have to round. 0.4 repeating. Or 0.44. Which equals 44%. All right. So the only other kind of problem that I wanted to cover, and I have already shared the assignment with you guys, but let me pull up one of the questions, because one of the questions does involve a situation that we didn't cover here in the notes. All right. There we go. So this says at a recent swim meet, half the swim club members experienced an improvement in their race times over a previous swim meet. The probability of a swim club member experiencing an improvement in their race time and training the week before the meet was 30%. What is the probability of the swimmer training the week before the meet, given that his or her race time improved? So the hint here is to create a frequency table, okay? Now, the frequency table in this case is not going to be, you don't know how many swimmers there were, but we do know some percentages, okay? So I'm gonna redraw this a little bit bigger. All right. All right. At a recent swim meet, half the swim club members experienced an improvement in their race time over the previous swim meet. So there's basically two things happening. Did they improve, okay, or not improve? Right. And the other thing was what's the probability of someone trained the week before or not trained? So when they either trained or not trained. Okay, so let's look at these different probabilities. We had improved, not improved, trained, not trained. Okay. So half the swim club members experienced improvement in the race time than the previous week. So that'd be 50% here, 50% here. And training the week before the meet was 30%. So improving in the race time and training. So improving and training was 30%. Okay. Now from here, we should be able to get a lot of these other percentages. Okay. Such as that's 30%. We know 50% is the total. 20% is here. We know this is going to be 100%. I think that might be all we can fill out with this one, but it's probably enough. probably some are trained the week before the meet, given that a race time approved. Race time approved training, so it'll be 30% out of the 50. So you have 30 out of 50, which is going to be your 60%. That's why it's going to be a higher percent, because we're focusing on the condition that the race time approved. But again, I wanted to show you how you can, even if you're only given certain parts of it, that you can fill out some more of the table. And even though they don't give you a table, you can make your own table.